Hello everyone, it's December the 3rd. Alright, another late night. Let's do this first. I said I'm going to try to think about this, but I actually didn't think too much. I did give a little bit thought while I was taking a shower today. I might have something, but I'm not quite sure. I have to really get down and then write it out to see if it works. But anyway, let's finish this one first. So we've done this before. Minimum average difference. Okay, zero indexed array, average difference of the index I is the absolute difference between the average of the first I plus 1 elements of the nums and the average of the last elements. Both averages should be rounded down to the nearest integer. Rounded down to the nearest, just call the int. floor. Return the index with the minimum average difference. If there are multiple, return the smallest one. The absolute difference of two numbers is the absolute value. Also, we're taking the absolute value. Average of n is the sum. Okay. Oh, then just prefix sum, right? You do prefix sum, and you don't even need to do prefix sum. Oh, that's exactly the same problem as, is that the same problem as we solved yesterday? Absolute average difference is absolute difference. Okay, the absolute difference. Yeah, I think that's exactly the same as the one we had yesterday. Okay, exactly the same is a wrong way to say it, but you know what I mean. What I mean is just this is the one that we use the same technique as we used yesterday. I forgot which problem we used yesterday, but it's the same technique. Basically, we're gonna have the whole sum, and then we start with the first one, right? We start with the first one. So we say let sum, it's gonna be 0, and the right sum, right? Left sum 0, right sum is this thing. Let's say 4, any nums, right? And we're gonna say res and min diff. Okay, res doesn't matter what it is. Min diff is gonna be this, right? And then we say this is plus equal to n, while this is minus equal to n. We need to go I. Right? And we say if ABS this divided by it'll be I plus 1, right? Minus this divided by, oh, actually it already tells you, right? So it's going to be n minus I minus 1, right? Tells you how to calculate this. If absolute difference is smaller than min diff, geez, let's do it again. Current diff, okay? Right, so we say if current diff is smaller than res equals I, then min diff equals current diff. Do we need to do one more when it ends? I don't think so, because at the end, and the last one, this should be 0, right? And I have this, and I will handle, yeah, I think I can just return as is. Let's see, this 3, this should be 0. That's good. That's kind of edge case. Nums minimum diff. What's wrong? 0 divided by 0? Shoot. How? Oh, because the last one. Do I have the last one? The average of index 0, 1, 2, 3, 4, 5. Oh, that's 0. So, and then we avoid this because it's the beginning. Index 0. Yeah. Okay. Man, if else 0, we'll put a parentheses around them. That's interesting. 0, 1, 2, 3, 4, 5. I got 5. What? That is bonkers, man. That is bonkers. Hold on. Yeah, basically just get the whole thing. Shoot. That could be. Hold on. I might know why. Let's put a parentheses around. Nope. That ain't the problem. Okay. That's okay. It's totally fine. Alright, so start with 2 and 25. 10, 20, 21, 27, 25, yeah? It's 3. Oh, God. My bad. But I like it to do it this way, yeah. I have confidence. I think this one shall work. There we go. Two, 2, 5, 6. Track of the left and right side. Okay, that's that. We don't want to see brute force. You know what? We should just check our previous result. And compare it to the right now. Yeah. I'll just do one more at the end. It's the same thing. All right, back on this one. Yeah, so I have a little bit intuition that tells me to find a palindrome of length 5. That means we need to find a palindrome length 3, all right? And to find a palindrome length 3 is actually quite simple. So what I'm thinking, all right, what I'm thinking is there are 10 digits, right? So for each digit, we're going to have a bunch of indices, right? So we can say I1, I2, I3, to I whatever I am, okay? And then all of these represent the same digit. And then as long as these two indices are 1 apart, right? More than 1 apart, then the number of digits in between represent the number of length 3 palindrome we can find. So let's say if we just consecutively find the number of palindrome that we have, okay, in between, can we do a prefix sum such that we know the number of 3 palindrome ending at a certain spot, right? Because if we can find the total number of palindrome ending at a certain spot as a prefix sum, then we can actually do start. Okay, we start with this is going to be this. We start with this to this is going to be, the total of this, right? Wait, hold on. Is this plus this? Hold on. If I have I1 and I2, if I have, let's say, 2, and I2 and I3, if I have 3, right? So between I1 and I2, I have 2 palindrome. Like, you can just like say 0, 1, 2, 0, right? I have 2 palindrome of length 3. And then from this we have 3 in between, right? So this one will have 2. These will have 3. But what if from this one to this one, how many do we have? Well, we have 1, 2, 3, 4, 5, 6. We have 6. 6 in between. Okay? We have 6 in between. So the question is if I know, like, this is going to be 2, and then at this point, because ending at this, right? So ending at this we have 2. Ending at this we have 6. Right? And then just ending at this point. Now I need to find palindrome of size 5. Then I get something and I get something, right? So I need to find the total number of 3 palindrome in this range. Okay, in this range, I need to find a palindrome in this range. How do I find? Can I use this to find a total palindrome? Answer should be 3. But what we have now is 6. The number of the same need to be taken into account. Hold on. So let's say we have a total number of this. That's accurate. Okay? That's accurate. So I have a total number of this. And then I also have the total number of this. Yeah? Because that's from the start. So it's going to be total number of this. Because the total number is going to be... But you can compute it directly. Right? You don't need... Now, I think we're back on square 1. Yeah, we're back on square 1. We're back on square 1. Hold on. So if I have this, okay, and I know the total number of 3 palindrome inside, which basically means we'll have a total number of 5 palindrome on this side. Then we'll go to the next one. then I'm gonna have the total of this. I have the total 3 palindrome on here. Now the question is, what's the total 3 palindrome? Because I start from here, right? I know the total here, and now I have here. So ending in this. So I need to find this. We can compute this, right? This we can compute. But how do I take advantage of this, or the 3 palindrome here? How do I take advantage? Because we're ending here, I can say these two are the boundaries. Now I need to say this and this are the boundaries, right? So these can be reused, no problem. These can be reused as well. That's interesting. The 3 palindrome here will pair with this, right? And the 3 palindrome here can pair with this. And are there any crossing? Yeah, there should be crossing. How do we handle the crossing? Then we have to compute the 3 palindrome in this range. That's something we want to avoid computing. Have the total 3 palindrome here, all right? Which basically is just the total 5 palindrome that can be formed from this to this. And then I try to extend, right? I want to extend to this one. So I have the total here, and I have this here. This we can compute. So we add these together, right? And then, because we have to also consider the palindrome that cross the center. Ooh. I don't have a good solution. I don't, man. too much computation. Man, that's doable. If I find all the three sum, and then I have all the five here, or we can say we have all the three here. Which means if these two are matching, right, these two are matching, I know we definitely have something matched to this, something matched to this. And then we can swap this with this. Then all of these will work as well. So a bunch of this one here, that's the newly added. We can do the swap, so we'll just increase naturally. Okay. But then we also have the crossing. How do we handle the crossing? No idea. There are 100 possibilities for the first 2 characters of the palindrome. Huh. Huh. Oh my god. It is a 3. It is a 3-lens palindrome problem. Oh my god. Oh lord. Oh lord. Yes. Holy crap. Holy crap. That is correct. So we try every single possibilities. It's only 100 of them. My god, you gotta be kidding me. Dude, you gotta be kidding me. So we pick the first 2, going through them, find where they occur, and then count. Oh my god. My god. I see how this one's going. Is it dynamic programming? This one doesn't seem dynamic programming to me. I mean, if it's AB, right, I need to find BA. So we find all the occurrences of AB. I find all the occurrences of BA. I find all the occurrences of all 100 possibilities, right? Then we have their indices. And then we go to AB, right? So the first occurrence of AB, I do the first index. And then, yeah, we'll go one by one in indices. So we'll go 1, and then we try to find BA. We can we don't even need a binary search. So AB, and then we go BA on the first one. If it's larger, if it's smaller, then we cannot use. So we keep going until we find a larger one. Okay. Then we can use this, we can use this, we can use this, all of them. So we're gonna do this minus this, right? This minus this minus, add them all up. So that's that. Then we move this forward, right? And if it's still good, we do everything. Okay. So that's AB. And then what? Then we do the next possibility. And then we see if it doesn't exist. If it exists, but it's in the front. But it's only 100. Okay, let's try this. Wow, that's quite smart, isn't it? All right, we're gonna do default dict. Yeah, we just try it and then see how it goes. Indices equals default dict. Okay. Then, oh my god, the 100 for right? It's actually hold on. Digits. There we go, that's the one. For di in string digits digits. DJ in string dot digits. Okay, so you can say D equals DI plus DJ. That's our thing. And then we just, for I in range len s. So I can say n equals len s. Actually, we can say 0 to n, 2 at a time, right? We say if si plus 2, right? Is equal to D. Nah. No, we can just go through. No, wait. It's subsequence. Oh, that's not that's subsequence. Wait, hold on. That ain't right. Yeah, it could be this. Oof. No. No. That's not the way to go. But it's similar idea. So again, we go each digit, okay? Each digit. So if we got each digit, their indices. Let's say we are at 0, right? And the first one is 0 and 0. So we find 0 and we'll find another 0. And then one pointer on the first 0, the second point on the second 0, and, well, they cannot point at the same thing, so we're going to point in here. And we say, okay, how about we pair these up? And we pair these Now we need to find all possible occurrences of 0, 0. Oh. Hold on. All possible occurrences. Okay, let's say 0, 1, and then 0 we have, hold on. Okay, so to pair 0, 1, we just need to find the last one. Okay, and then we say go from here, then we go from the first one that can pair with it, so everything can pair with this. Then we need to find a 1, 0, right? Then 1 will be the front, right? So again, and then find this. That's how we can pair 1, 0, right? So with this and this, so we need to find a pairing. With this situation, so the earliest pair. Then we can find the earliest pair. Then they can all pair. But in this case, there's no pair, right? This and this is no pair. So we have to move to this one. Okay, now we find the first one. And for this, we're going here to find the to find a pairing. What do we need to find? Because this one going this way, it gets smaller and smaller, right? And then we need this one to get bigger and bigger, which means we start from here. No, we start from, because we want to find something bigger than this. We have something bigger than this. Just this plus 1, right? And then we just need to find something bigger than this. So we go, yeah, we locate the 2, okay? And then now this one move this way. This one move this way. So we know total number. And this, because I move once, this will move once. Nah. We'll still need some time. I don't know, if ending at this, how many? I need the total number, okay? Which is calculable, and then we just move on here. How many? Move on here, so we have all the numbers. So 0, 1, while ending at this, I have a certain number, I have a certain number, I have a certain number, I have a certain number. So I have all the numbers. Ending at this one, the total number. Now, for this, the same thing. Starting with this, okay? We can also say ending, or we can say starting. It's the same thing. It's the same thing. Okay, we can say starting with this, like 0, 1, right? And then we starting when 0, 0, 0, 1, 1, starting with this 0, how many I have a number. Starting with this 0, how many I have a number. And then we have 1, 1, 0, 0, starting with this one, how many, this one, how many. Okay, so we can produce this kind of a library. And then when we need to compute, I say, okay, give me this 0, 1. So we look in this one. I have that many, right? I have that many. And then we say, because 0, 1, 1, 1, 1, 1, 1. Oh, I can't. I have to say ending. Yeah, it has to be, one is ending in 1, the other will be starting with 1. So we say ending in 1, I have, I'm going to go 1 by 1, right? We ending in this one, let's say I have X number. And we just say ending in this, we have 0, 1, 0, 1, 0, 1, 0, all of these, they're all possible 0, 1s. And then we want to know 1, 0, how many? Now, the possible 1, 0 is going to be, no, as long as the one next to it, I have 1, 0, I say I have that many 1, 0s. And then the next one I have that many 1, 0s. The next one I have that many 1, 0s. And to calculate that, I just put a 1, and then I can go up, right? If it's here, I can compute how many 1, 0s I can produce starting with this. How many start with this? How many start with this? How many start with this? That I can compute. Okay, I can pre-compute it. And once I pre-compute it, I can say if ending in this, how many? The total number of 1 zeros I can produce. That's actually, I shouldn't use total number because I can do this with this. Because it could be all different combinations, right? Like I say, if I have 10 on the left side, I have 5 on the right side, right? I have to do this, this, this. Then each one can pair with all of them. So it's 10 times 5. And because I just pick one. Then times how many is in the middle? Because I can pick this with this, this with this, this. So it's this times this times this. Alright, and now we move on to the next one. This times this times this. So it's this times the sum of everything, which is just the prefix sum. Right? The total of this towards the end. Total of this towards the end. Total of this towards the end. So I have the total. What I need is from this to what's the sum of this. Yeah, that's just a prefix sum I can get. Okay. So I compute the individual, like starting from, so if I consider 0, 1 and 1, 0, I compute individual 1 zeros, how many, and then we loop through every 0, 1. Oh no, it's not multiplied at the same value though. This times this value can change. But anyway, we'll produce that, and then we can say from this index I can produce how many 1 zeros. All right. And then from the next one, I'll move up. Man, it still feels a lot of computation though. Because when I done 0, 1, 1, 0, now I have to switch to 1, 0 and a 0, 1. Alright, see the second hint. Let the current character be the center. Man, I didn't think about that. The current character is the center. Hold on, so I have current character in the center. Then what? Then I look to my left to find how many, let's say 1, 0 I have. And I'll look to my right to see how many 0, 1 do I have. Okay, so this is what I have. Then I look to my left. I have all the position of 1s. I have all the position of 0s. But how do you compute? How do you compute the total count? If I can count the total number of, like, say, from a start to a certain position, the total number of everything, of all 100 possibilities, that would be very helpful. Let's say I know the total number, okay, of all 100. 0, 0, 0, 1, 0, 2, 299, right? Let's say I know the count of all of them. Now, I add a new value, a new digit. Yeah, and it's not really adding a new digit. I'm current a current one, and I go through everything. And I also know the total on the right. How do you know the total on the right? Yeah, how do you even know the total on the right? Let's just say you know, right? And then I need to add the current. Let's say current is a 3. If current is a 3, then what? All the 0 3s, all 0 3 that we have in the past. Hold on. Hold on. Like let's say we have 10 0 3 at before, okay? We have 10 0 3 at before. Now we're gonna add another 3. Then all of those 10 0 3s, they still holds, right? They all hold. And because I have 3, so all the 0 3 we already have, those 0 can pair with this new 3. So we will double it. There'll be 20 of them, right? In addition, all the zeros can pair with this 3. So I need to count the number of zeros so far. And then they can all pair with this 3. So it's going to be the previous 0 3s, and all the zeros can pair with this new 3. So that's gonna be add. Then we can have the count. That's how you have the count. So we're gonna do a left to right, and we'll do a right to left. We'll go 2 rounds, so we'll collect all of them. We'll collect all of them, and then, my God, this might work. Hold on, that's not how we want to do it. So we're gonna have a left to right count, and then we have a right to left count. So when we do this, I know the right to left count is a little bit tricky to deal with. So this is gonna be that. So we're gonna just count this, and this position is right to left. That's actually not right to left. That's still left to right. It's still, so it's from this to the end, right? This to the end. So this position is this to the end. This position is this to the end. So we just add this, add this, add this, add this. Okay, so the total number of this and total number of this, we add them together. We multiply them together. Let's try. No, this is not what we want. What do we want? Well, we need to count number, so the digit count, right? So we're gonna say DC This is a digit count. And single digit count. Double digit count. Double digit count. Okay. Single digit count. Double digit count. Counter. Nah, that's... So we have single digit count. So we have a new one. Then it's just going to be the single digit count. So we're ending at this. So the double digit count. Hold on. What do we want to create? What I want to create is at any position, right? I need to know the total digit count of everything. So if I can have the total digit count, okay, hold on. Single digit count. That's fine. So we add a new one, and then we say when we add this, we have the digit go through everything, because that's the new one, and we add to them. Okay, so at the end, I have the total digit count for all possible digits, right? Then we backtrack. So we backtrack 1. Then we create a new one. So we're losing, right? We're losing a digit. So everything that ending in that digit, need to remove by certain amount. So that the count on that side. So we're going to go right to left. Oh, this is going to be very interesting if I can implement this. Okay. Calm down. Let's try this. We're going to just go left to right to fill up everything. Okay? We're going to fill up everything. Well, technically, yeah, let's fill up everything, and we're going to build stuff from right to left. And we can remove from left to right. That's fine, because we have to have 5, right? Which means we'll go all the way until this one. I don't even need to have this one. I can go all the way, I can compute everything to this, then I stop. And I compute everything to this from right to left, then I stop. And then we just move it one by one. Okay. So for I, let's implement this. I'm excited. Now this is gonna be n minus 2, because n minus 1, n minus 2, n minus 3. Actually, no, n minus 3. I want to remove the last 3 digits. Smaller than 5. Return 0. right? Smaller than 5, you don't have anything. So if you have 5, right, 5 minus 3 is 2, so 0, 1, right? I'm coming in here. Oh, what we do is, well, for everything, single digit count, si plus equal 1, right? So I'm adding my current one. Actually, I should do this at the end. What I need to do is go through everything, right? We should say for d in single digit count, k key and value in single digit count, double digit count, double digit shall equal to this k plus si, right? So it'll be double digit with plus equal to v, because this is the new digit ending, right? And then I have the a single digit count, so all of them can pair with this, right? And then we have to increment, right? Increment. So it's going to be that, right? We're going to do all the single digit to pair with the current, and then we add to the double digit count, right? So now we produce the new double digit count, right? Everything ending and my current one. And once I'm done, I do single digit count plus equal 1. So this will produce what we want. And we have to say there's going to be left to right, right? Left to right. Left to right. Single digit count. Now we're going to do right to left. Okay? Right to left. Right to left. And this is going to be for I. Let's call it j in range. n minus 1. All the way to n minus 3. Also, we don't touch. N minus 1, n minus 2, n minus 3. We don't touch this one, because this is the starting point, right? So we're actually just getting 2. Again, I think we can just copy and paste this entire thing. It will be the exact same thing, right? So this, oh shoot, left to right. Right, and this is going to be right to left. And then this is going to be j. And then right to left double digit count equals everything that we have, the double digit. Right, add a current one, plus equal v. And then we say right to left double digit count, single digit count. It's j plus equal 1. Okay, so by doing this, we'll produce the two things. Now we can say, you know what? For let's use j I as well. It's okay. We can repeat using I. Now I want to use j. Okay. So now go from right to left. I mean, we can go left to right. It's the same thing. But I just go from right to left and consider each digit as the center of the palindrome, right? Find out how many 5 size palindrome can be formed. So for j in range, doesn't matter, n minus 3. Now we start from this. I'm going to go all the way down to 0, 1, 2, right? So we have to go 2, but we can go 1. Okay, this is my center. Now what we want to know is for everything on my right, how many is on the left? Because we go right will be easier to do. So what we do is for double digit and v in right to left double digit count. Okay, for everything from right to left a double digit, we have this count. Now what we need to do is from the left hand side, right? From the left hand side, we can have a res shall plus equal to left to right double digit count of dd reverse. We're going to find all on the left. In fact, this has to multiply by v, because everything on the right, I can pair anything on the left, right? They can just pair however they want to pair, so it's a multiply. So we do res plus equal to this, right? To find all of them at most 100, and we are done. All right. Now, once we're done, we can actually even be cheekier. We can say if lan, yeah, we say if lan is smaller than left to right EDC. We do this. Else, we can do the reverse, because that's basically the same. But we are guaranteed we always use the smaller version. Okay. Now after that, which means we handled all of them, and then the left to right DDC need to remove the current one. The right to left need to add the current one. So how do we remove? Well, what we remove is for every single one, right? So we need to remove dd ending in and in what? In sj, right? From left to right EDC. How do we do that? Well, man, I have to add it, because if we go to n-3, then I'm not even including n-3. So we shouldn't even delete it, because it doesn't even exist. Lordy. Hold on. So I have this. Yeah, because the setup didn't include this, right? So I have this and this. Now we'll add, once we're done, because we move on to here, then we remove. Oh, shoot. Should be j minus 1. All right, shall be j minus 1. Because we move to j minus 1, right? So the j minus 1 need to be removed for the next round. That's okay, that's fine. So what we're gonna do is the single digit count. Right, so I want to remove everything ending in this, right? So we have to have everything else, not including this, everything else, and then the count before it. So I have this count, and we have to remove. So that will be here. So what we're gonna do is left to right single digit count, sj minus 1, then you have to minus equal 1. And then for k v in left to right single digit count dot items dd, that's fine, we're gonna call it dd, equals k plus s j minus 1 and oh, I don't have to. It only occurred once. Let's do this. Shouldn't that be si plus k? No. Wait. Hold. I want to find all of them from this up into here. Now this is saying everything ending in this. Wait, hold on. I don't just want ending in this. Oh, it could be like just starting in this. Wait. Hold on. If I have everything, and now I add this. So it should be everything, and yeah, I think this should be si plus k. I think this is si plus k. Because that follow the, yeah, you add this, so this is new. We added new, right? So everybody that's in the single digit count, this can pair. That's the new pair. Okay. Okay. So this I'll remove, and then I can say left or right double digit count. This minus equal v. Right? Basically saying I'm removing everything that ending in this. Right, so we have for the single digit count up until this one, and then this, and this doesn't exist. So I'll remove all of them. Okay. Now we say add dd beginning starting with j to right to left ddc, right? So we add sj and we do the same, right left, no, for kv in right left single digit count, right, single digit count, currently what we have, and then right left double digit count, sj plus k plus equal v. And once we're done, right to left single digit count, sj plus equal 1. And we'll return rest. Not sure. I mean, honestly, because that's only 2, so we don't really have to do this. Single digit count could just be s minus 2 to the end, right? That's a single digit count. A double digit count, because we only have one. We only have one. We can just say So I can save all this. Right? It's right to left. Single digit count is, yeah, that's right. And double, because we want to have 2. So double digit count is just going to be this one. We have 1. And then we'll add another 1. So it's going to be this plus whatever we have. So they can be incrementing. Okay. I don't know. Let's try. Oh, jeez. 2. That's a good test case. This is only 2. Ooh, this is correct. All right, let's throw some choice. Okay. How many? Let's do 10. Okay, for this in range, let's do 10. Let's start with 10. Choice string dot digits. Print. Nah. Still 100. And 100. Be bold. Because I have to exit in order to copy and paste. If it's not right, then we do something else. Looks very promising to me. I'm gonna go for it. And right. Oof. I think we're on the right track, but way too much. Interesting. Can we... Damn, that's a lot of digits. Oh. Did you remove? And that is one thing I never remove. So okay, I can choose to remove. can say if I can remove this. Yeah, I don't think that's the reason though. Yeah, I don't think that's the reason. We're still gonna pass this, and we're still gonna fail the other one. Man, that's not the reason that we fail. Okay, that's our common trick. Damn. Damn. I have no idea. I'm just, trying to see if we can narrow it down. Oh, come on. What could be the error? The logic seems perfectly fine to me, honestly. I don't know. I have no idea. Can we even just remove one? My God. Oh. Nope. I mean, even if you find it, what was it? There gotta be some edge case that I didn't consider. I know why. Yeah, I know. This has happened, it's not the first time. There we go. Because this is only 10. Maybe I don't need to do this. That's fine. Yeah, I was thinking maybe I need to do this mod thing. Do you think you should do the mod at the end or do the mod along the way? I'll do it at the end. Got it. I'm gonna end today. It's very important that we recreate the whole thing tomorrow. And yeah, but this idea is very valuable. First, we can get all the possibilities, yes, and then this is the same thing, the same idea as like I think I solved this type of problem maybe 3 or 4 times. You keep track of the left side, you keep track of the right side, and as you move on, and then you just make small changes on both sides. Yeah, good solution. Very good. Okay, that'll be it. We will revisit this problem tomorrow and write down what we think. Okay, I'll see you guys tomorrow.